Hello. So I didn't get a fun fact, but I can tell you a fun fact. It's that I'm really nervous, actually. And the reason I'm nervous is because this is a really big room. I look around and I think, man, crikey. This Go thing has really gotten out of hand. And I think that's an amazing thing. And I really want to thank everyone involved in the project, all of our contributors, and all of our users, of course. And in particular, the organizers of this conference, Brian and Eric and their amazing production team, all of the sponsors of the event, of course, and the amazing speakers who genuinely have given me a lot to think about over the last couple of days. And of course, Kelsey, for being hilarious and wonderful. And I suppose if I'm the eyes and mouth, then Kelsey's probably the soul of this conference. I also want to thank all of you. Thank you so much for attending and being here and making this such a great success. So before I get into my talk, I just wanted to say a few words about the community. And basically, I'm incredibly proud to be part of this community. And since I started working on Go more than 5 years ago, I've learned an incredible amount from some really remarkable people in this community, many of whom I'm lucky enough to call my friends. And standing here now, I feel so much positive energy and enthusiasm, even after 2 whole long days. We're gophers, right? Applause. Come on, give me something. That's great. But also, when I look around, I also notice that a lot of us look pretty similar. And as Russ mentioned in his opening keynote, Go needs everyone's help, and everyone isn't here. And if Go is to succeed, it needs ideas from as many people as possible. It's been my personal experience, and it's also well documented in academia, that diverse teams are more innovative, creative, and adaptable than monocultures. Diversity is strength. Diversity is longevity. A couple of weeks ago, I proposed a code of conduct for the Go community. The code of conduct is a document that specifies a basic standard of respectful behavior, a mechanism for reporting issues within the community, and a framework for resolving conflicts when they inevitably arise. I truly believe that this is a vital part of bringing more people into Go, and so this project and its community can continue to grow and prosper long into the future. I think it's still early days. If you have ideas about how we can improve things, or if you just want to learn more about these issues, I really encourage you to please join me at a session tomorrow at the Hack Day at 1 p.m. So we can discuss this stuff. I truly believe that with your help, we can make this the most friendly and inclusive community in the tech industry. That's a sincere goal. I also believe that Go's success depends on it. So in this talk, what I want to discuss is how Go was made, how it came from being a small side project at Google to this huge open source project that involves all of us here. And in particular, I want to talk about its development process. How has the process changed over time, and also what the future of that process is. So it's already been discussed a couple of times in the last couple of days, but Go began with 3 friends, Robert Griesmer, Rob Pike, and Ken Thompson. And the story goes that between waiting for a large C++ project to compile, they had a thought experiment, what should a modern, practical programming language look like? And in those early days, the design process was pretty informal. They had design discussions in person, and sometimes when they were between continents, they would have them by mail and video chat. Even in those really early days, in fact, especially in those early days, it was a consensus-driven process. That is, they only accepted features that they unanimously agreed upon. And as Robert mentioned this morning, most of the proposals made by members of that very small group were outright rejected. It was a process of design by attrition almost. So the very first artifact of Go was a language spec. And in fact, you can find it in our repository. This is the Git hash of the repo. And in fact, the whole of Go's history as it's recorded is in the core Go repository. We were very careful to migrate it between version control systems as we moved from one to the next. And that really is because from the very first day, we had open source as a goal. And we wanted to make sure that that history was preserved, even from those early days. Robert actually showed some of the notes that ended up in this doc. And you can see it there in the repo. You can see that it's not just an initial spec of the language, but also a set of goals and aspirations for the language. So I suggest you check it out. It also includes the very first Go program, which Rob showed in his keynote last year, which is the prime sieve. And it's interesting to note that this actually looks pretty similar to Go code today, with some obvious differences. And so it actually took a while for the team to get started using version control for Go. It was about 3 months into the project, I think. And Subversion was their very first version control system. And they actually did about 400 commits this way without any kind of code review, just 3 people trusting each other to do the right thing. You can actually find the very last Subversion commit they made, which was in July 2008. And it has a very early version of the spec, a Go compiler, which targeted Linux and Darwin AMD64. And it's actually the same Go compiler that we're using today. So it's lived that long. A few early standard library packages, which are very interesting to look at, actually, and some test programs. And you can see what Hello World looked like in those days. But after a few months of using Subversion, the team and their management decided to get a bit more serious about the project. And so they migrated all their code from Subversion to Google's Perforce installation so they could take advantage of Google's code review platform. And shortly after that, the team began to grow. Russ Cox joined Google and the team in August. And Ian Lance Taylor actually showed up one day literally with a working version of GCC Go that was written based on the specification that they had in their repo. And so they quickly welcomed him to the team. And about 20 other Googlers were involved in the 20% time between July and the time Go was released. So making changes in the early days was pretty straightforward. Everyone knew everyone else. There were pretty much no users, and all the Go source code was in the one repository. So while the workflow was pretty informal, it was still design-oriented. And as I mentioned before, the team was prepared to wait for good designs to arrive. Many of the problems that they stated in that original spec didn't have obvious solutions. And so there are some things that they lived with that were quite awkward for quite a long time. For instance, they knew from day one that there would be reflection capabilities in the language someday, but it took them a really long time to figure out how that would work. And they also knew that the string formatting package, FUMPT, would be driven by those reflection capabilities. But without them, they had to put up with this kind of awkward chaining API where this S method is basically the equivalent of %S, and this is the equivalent of %E. And you can see that today it's a lot nicer. But they dealt with that because they knew that it would get better. Another example is that slices didn't enter the language until about 18 months into the project. And if you think about how often you use slices, it's truly remarkable. Before then, they had these open arrays, which no one really seems to remember exactly how they worked. But here's an example that I pulled from the container vector package in the standard library, where whenever they needed to extend the length of the vector, you would have to allocate, like 10 to the n elements. So you could only allocate in powers of 10, and if you needed a list of more than 1,000 elements, then you were just out of luck. So to give an example of how an early language change went down, I want to talk about the case of star-chan and star-map. So in the early days, the map and chan types actually had an asterisk in front of them, and that was just to denote that they're pointer types, essentially, as they are still today under the covers. But the team had a meeting, and the issue was raised, and they discussed the pros and cons of removing the asterisks, and then they made the decision to remove them. So they all headed back to Russ's desk and sat down. He sat down, they stood behind him while he made the compiler change and literally opened every Go file in existence, removing the asterisks. I presume you used set or something like that. Probably. Sam, of course. But you can see that this is a rapid approach, and probably many of you who work in small teams are familiar with making changes like this in this kind of manner. But it's obviously something that doesn't work once you have users and a community. So in mid-2009, the team started preparing for the open source release. And they moved to their third version control system, which is Mercurial, and we used readveld for code review. And we used that system for the next 5 years before transitioning to Git at the end of last year. If you look at the very last perforce commit, which is on October 29th, you can find it looks very similar to how it did on release. We have a mature spec and compiler. We had a broad standard library with HTTP and JSON encoding and so on. We had the tools like GoFumt and Godoc and Cgo that we're familiar with today. The testing framework, and of course, plenty of unit tests. And most importantly, we had a lot of documentation. There was even a Go tutorial. So the open source release was on the 10th of November, 2009. And it was a fortuitous day. We got to show the world the beautiful website with Russ's great video. And the response to the release was huge. And the team at the time, which didn't include me, but the team was totally overwhelmed with the level of attention and feedback. And so they kind of scrambled to respond to mailing lists and IRC and so on. But most gratifyingly, changes to the project came in on day one. This is the first change from Kevin Ballard. And he sent a fix to an eLisp file, which is a little bit deflating. But we'll take our victories where we can get them. Some Emacs fans in the front. Get out. But the nice thing was that in the first month, 32 people from outside Google contributed to Go. And that's more people than from inside Google had contributed to Go at that point. So clearly the contribution process was working. So after the release, the team continued to work on the language. It wasn't done at that point. But obviously with the community, the process is different. About a month after the release, Rob sent the first change proposal, which was the proposal to remove semicolons. Who here likes semicolons? No hands. Happy. So the proposal was in the form of a design document. It was a lengthy email which provided background for the change, the rationale, and a formal specification of the change, as well as the plan for implementation and examples of what it would look like. And so the design doc was shared with the community, and Rob asked, please read the proposal and think about its consequences. And the response was generally positive, and there weren't really any major suggestions about how it could be done differently. But the proposal was implemented, and most of the changes were made mechanically by GoFumt. And this change process and also the mechanical completion of the change would be the shape of things to come. So there were many proposed changes to Go, but the team was really careful to curate the changes that made it into the language. And remember, this was a team that had already been throwing out their own ideas for years. And so they were really prepared to just wait for good ideas to come along. And so, many more things that were suggested were declined than accepted. And that's just because some of those ideas fit with the project's goals, whereas a lot of them didn't. One of the early accepted proposals from the community was to make the slice bounds upper and lower optional, so it just defaults to 0. And an early decline proposal was to have negative slice operations work, kind of as they do in Python. And yeah. But I think, at first, as a project, we did a bad job of communicating the goals of the project and also our development and design process. And this really frustrated people. People said, why are they just saying no to everything? Even though it's not actually true that we said no to everything, it appeared that way because we said no to so many things. And people were frustrated by it, and it took us a long time to really articulate why. And it was Rob Pike's talk in 2012, Go at Google, Language Design in the Service of Software Engineering, that we were able to properly articulate why and how Go is. And I really wish we'd had this document from the very first day of launch, but Rob assures me that we couldn't have written it then. We simply didn't have the perspective on the project and what we were doing to truly understand what we were doing. So if you haven't read that talk, well, it's actually in the form of a document. I suggest you read it. In thinking about all this stuff, I had a thought, like, what if Go had just been open source from the very first day? What if Rob and Robert and Ken had created a mailing list and just started all their design discussions by mail? I think, it really would have been easier for people to understand the project. They could have seen how the language evolved. They could have seen the trade-offs that were being made, the design decisions as they were being made. And so it would have been a lot easier for people to sort of be on board with Go's vision from the beginning. But I don't think it's quite that simple. You also sacrifice things by exposing these early ideas, because ideas are really fragile, and particularly for a programming language which is not just an idea, but actually a collection of ideas that are interrelated and interconnected. And so, I think you really need to nurture such ideas and processes before you can expose them to the outside world. So with all this change happening, we had to manage that change. And initially, we did that through weekly snapshots. Put your hand up here if you ever synced to a weekly snapshot in Go. All right, that shows your age. So weekly snapshots were an early attempt to keep everyone in sync. Every week, we just pick a weekly stable revision and write the changelog. And this is actually the first task that I took on when I joined the team, was to issue the weekly snapshots, taking that off Russ's plate. And it was a bit of a grind, but it was great for early adopters and developers. Everyone could keep a handle on what was going on in the project. But there were also problems. Contributors tended to work at tip. Users would sync to the weeklies. Contributors and users would get out of sync. And people found it annoying to update weekly, and so they wouldn't. And then when you updated less often, there would be these huge change logs to trawl through to figure out what changed and what broke your code. So we got terrible version skew in the open source community, and it really fragmented everyone and ultimately slowed the adoption of the language. So in March 2011, we introduced releases every 1 or 2 months. So we'd just pick the most stable of the most recent weekly snapshots and then announce it with just the Cliffs notes on what needed to be changed between revisions. And this kept people more in sync and reduced churn, and it was very popular. But we still had skew. This time, the real Go fanatics and developers were synced to the head of the repo, while users would be like up to a couple of months behind. And so, there would be skew present even then, which is frustrating. One way to try and address this was the creation of the gofix tool. And gofix is based on the same technology that powers gofumpt. Who here ever ran gofix? All right, well, that's cool. And so it was like gofumpt, except it would make changes to your code to update for language and library changes. And so our release notes soon became mostly saying just run gofix, with maybe some comments for some changes that couldn't be made by gofix. And it was a great boon. It could do some really complex things. I know this font's a little small, but this is an example of a changelog from the redesign of the Reflect API. And when that happened, Russ wrote a gofix module to update reflection code. And you can see, if you can see, there are some quite sophisticated rewrites, like rewriting a type assertion into a simple comparison, or rewriting a switch case into several switch cases for all variations of an int, down here, for example. But even with gofix, we still had versioning issues. Because the language was the very root of the dependency graph, it really suffered acutely from this fundamental issue that the code that you wrote in Go today would not, or probably wouldn't, compile tomorrow. And this meant that many users, and in particular companies, were just unwilling to bet on this fundamentally unstable technology. There was also a general need for stability. Gofix made it really easy for us to make changes, and it makes it easy for us to experiment. But we then had this dilemma that when change became easy, it became hard to decide what changes were important. Everyone sort of harbored these desires to tighten up the language and libraries. But to do that, we really needed to plan ahead. And so at some point in 2011, we made the decision to design and implement a stable version of Go. And that was Go version 1. So Go 1 was a spec of the language and libraries that will be supported for years. We've already supported it for 3 years, and I imagine we'll support it for many more. Well, actually, we're committed to supporting it for many more. I don't imagine anything. And it was also the first version of Go that was available as a downloadable binary. And it was also an opportunity for us to knuckle down and fix these language irritations that were bothering us, fix some inconsistencies in the libraries, focus on bug fixing and to-dos. Because we had this greenfield project. It was very easy for us to get sidetracked building new fun things instead of the boring work of making everything work properly. We also took the opportunity to design and build a strong tool set, which is the Go tool, which was just such a step forward from what we were working with before. And probably most importantly for the uptake of the project, it was an opportunity for us to focus on Windows support. And it was really through the help of the community that we were able to make that happen, because none of us use Windows. On the team, I mean. And so it was really an opportunity to polish and refine the project rather than redesign everything. And so the process of planning Go 1 was the team at Google internally prepared a detailed design document. And we met, before meeting, some of us actually implemented some of the changes that we were proposing so that we could see how they looked. And then we met for a week to discuss the document. It was a kind of grueling week of day-long meetings where we just churned through all these decisions. But then Russ actually coalesced that into a really nice proposal document, which we sent out to the community so that we could gather the feedback of everyone else, so that everyone else could be involved. And you can see that there's a blog post which links to both the doc, the planning doc, and also the discussion, which is a really long thread on the mailing list in which we gathered essential feedback that was used to refine these proposals and made what has become the version of Go we know today. So as an example of one of those changes, there's the error type. Before Go 1, we actually had the type os.error, so package os exported an error type, and everywhere you had errors, you would be importing the OS package. And you can see here's the reader and writer packages, and that looks really weird to me now, but it was the status quo for a really long time. Before the meeting, Russ raised this issue in the design doc, and the fundamental issue was that a lot of our standard library packages had to import OS when they really had no business doing that. And he talked about a possible new design package error with a type value, and so it would become error.value. At the meeting, we discussed the issue. Russ actually presented some data. He implemented it, wrote a gofix module to do it, and we saw that it would work. You can see that there was some discussion. Ian raised, perhaps it's only an issue for the core library. And Brad and I tried to start bike shedding the name, and were immediately shut down. So that's fine. But the decision was that we would go with that plan and present that to the community. So note these weren't final decisions, these were tentative decisions. But on the list, we had a lot of great feedback about many aspects of the proposal. And is Roger here? I know he's in the audience somewhere. Just go, woo! Yeah. So Roger, who's told me last night that he's been using Go since day one, he proposed that it should just be a built-in type. So the language should actually provide, at the universe scope, the type error as an interface. And that was one of the decisions, one of the suggestions that were rolled in to the design doc. And actually, we refined it a little further by making it, instead of type error with a method string, it's now type error with a method error. And so in this way, and many other ways, you can see how the Go community and contributors have been fundamental in shaping what Go is today. So the process of implementing Go 1 was just a matter of creating a bunch of new issues on the tracker, having contributors, including the team, nominate themselves to address specific issues, and then just stop doing anything new. And we just focused on stabilizing the tree as best we could before the release. And Go 1 was a huge success. And I don't really think I'm being hyperbolic when I say that it did herald a new era for Go. Users clearly appreciated the stability. And this is the Google Trends graph for the Golang search, which is a very rough proxy for Go usage. And you can see that around March 2012, when we released, the rate of change increased dramatically. And another benefit of Go 1 was that it allowed all of the Go contributors to refocus their energies. So before Go 1, we were really focused on building new things in the language and in the libraries. But after Go 1, we had this compatibility promise. And so we had to focus on improving the implementation, improving the tooling, improving the ecosystem outside the standard library. And so I think that was really vital to helping Go continue to grow. We also, 14 months after Go 1, we released Go 1.1, and everyone seemed to agree that that was way too long. And so we switched to a 6-month cycle. And we stuck to that plan for 3 releases afterwards. And we actually extended the plan to 8 months, an 8-month cycle for this particular one, which was nice because we totally translated the compiler into Go and rewrote the GC, and there's been plenty of work happening in this cycle, so it's actually worked out pretty well. And that's due August 1, if you're not aware. So that's kind of how we got here, but I just want to talk a bit about, I should also say, between Go 1 and now, there's been a tremendous amount of work, particularly in the community, that's been really impressive. And that's really where the action has been, as far as I can tell. It's not really been in the core of the language. If you ignore certain significant contributions, like the race detector, for instance, which is a significant improvement. So I just want to talk about the future of change, how we're going to continue to change and grow Go as a language. And this whole talk is inspired by a sort of question that I asked myself a little while ago, which was, if Go's development process emphasizes this upfront design, and it has done from day one, and it's always been the way we've operated as a project, how come of our 450 contributors and so many committers, almost all of the change proposals were made by the Go team at Google? Even though they were driven by community feedback, it was still mostly the people on the team who were writing them. And to sort of understand this, I took a look at the contribution guidelines. And the contribution guidelines are very elaborate when it comes to discussion of code review. It's very thorough. It says everything you need to do to send a change and have it reviewed. But when you look at the section on design, it basically says, just when you want to write something new, send mail and discuss what you want to do. And does this describe the Go project's attitude to design? Well, maybe really superficially, but it doesn't really say how the design process works or how someone can be a part of that. As we've seen, the successful proposals that have gone into Go include design documents that discuss the rationale, the trade-offs. What do we gain? What do we lose with this change? And how will it be implemented, and by whom and when? So obviously, there's a gap in our documented process. So to fix that, Brad and I recently proposed a change proposal process for the project. And it's not an idea to put a whole lot of bureaucracy onto the project. Rather, it's an attempt to kind of codify and organize the process that we were already using so that it can be more accessible. And so the goals are really to make the process clear to contributors, and also critically to commit to timely evaluations of those proposals so that all of the core Go contributors know that it's their responsibility to take in and respond to these new ideas. And also to build a recorded history of all the proposals so that anybody who wants to propose something new isn't told, oh, go look at the mailing list, there was a long thread about this, which I've said before. And then in preparing this talk, I've gone to the mailing list to find those threads, and the Google Groups search sucks. So the process in brief is one of filing an issue, and then the contributors who are kind enough to triage issues on our bug tracker will triage the issue, and it might be a duplicate, it might be a backwards incompatible change, in which case it can be closed. But if it is a proposal that warrants some design, it'll be suggested to write a design document, and so the contributor can author a document following a template, commit that to the new proposal subrepository, and then invite the contributors to review that document. And then there can be a feedback cycle, refine the proposal, and then eventually the proposal will either be accepted or declined. If it's accepted, it will be implemented. If you follow this link, you can see my tentative doc, which is now a little bit out of date, which describes the proposed process in more detail. It's important to note that this process is an experiment. We're still kind of discussing exactly how that process should work, but ultimately I'm just hoping that it will make the process more accessible to anybody who really wants to get involved in the design of Go. So I just want to conclude. I think that over the years, it's clear that Go's design-driven process has served the project really well. I'm personally really happy with the results that we have, and I'm also really happy to have worked with this idea of waiting for the right design to emerge, because I think when you're working on something as fundamental as a language, it's really important to take your time and make sure that you get the details right. But as Go becomes more widely used by more kinds of people for more kinds of purposes, the community really needs a larger role in shaping its future. And I thank Russ for articulating that so well in his keynote yesterday morning. And so I'm really hoping that with your help, we can make Go's next 5 years way more spectacular than the last. Thank you very much.